So remind me again, who does physics here? Like pretty much everyone? Okay, so like everyone here except me. So that's fun. So you guys will be kind of more ahead of me in this in some respects, because I think that like the first time I looked at vectors, it was something new to me, and I kind of wasn't really sure how to approach it from a mathematical sense. I mean, how would you guys describe what a vector is, coming from your physics? Okay, so vectors are magnitude and direction. Is that how you describe it? Vectors are a force. Is that? Or I heard another one.
It's not the right word.
They can be like speed, like velocity or whatever.
Okay, so we're kind of throwing around a few different other things now.
Not velocity, not speed.
Why not speed?
Because speed is a scale.
Okay, so now we're introducing like other terms and definitions here, right? So, how do we describe a scalar if you're kind of talking about that? Okay, right, so that's kind of like the distinguishing thing when we talk about scalars and vectors, right? These are two different quantities, and scalars are a quantity with only magnitude, yeah? And actually, mathematicians are really good at working with scalars, because pretty much every quantity we've dealt with in the mathematics course thus far is a scalar, right? If you think about things like length, width, these kind of dimensions, there is no sort of direction involved. They're just a number, like 5 centimeters, right? So pi is a quantity, right? It's a value, right? So these numerical values, these are pretty much all scalars because they only have magnitude, yeah? But then when we talk about quantities which are vectors, we start introducing another aspect of them, right? We start introducing direction. Okay, so you start talking about things like, so not speed anymore, right? Speed is 5 kilometers per hour. That's a quantity. But how does velocity incorporate direction? Where does that come into play? Like, how do you describe the direction of how fast you're going in terms of velocity? North? Do you use direction? Do you use north? Do you use bearings in? Yeah. So bearings, right? I think also when we talk about velocity, we have positive and negative, right? Right. So that indicates a positive direction and a negative direction. Generally, positive is in the right, negative is towards the left. Yeah. It's not just velocity, right? There's other kind of like movement with magnitude and direction. So we look at things like displacement. And then we look at things like acceleration. Here's one for you to think about. What about this? Oh, wait.
That is a vector.
Why?
Because it's a force.
Okay, right. So I was talking that in mathematics we deal with a lot of scalar quantities, right? And kind of weight or mass, when we talk about in terms of mathematics, we just deal with a numerical value, right? We just give you a number. This person weighs 50 kilos, right? And hence solve the problem, right? But in actuality, when you study further into physics, weight actually is a force. It has direction. And F equals to mg, this is actually the force of gravity acting upon us when we're considering weight here. So that's just kind of idea of, what actually is a vector, and kind of what are we looking at here, right? What's the big picture there? Where does this all kind of fit in? So today, hopefully we can get through 1 and 2 here. These are like the first 2 kind of sections of the vector topic. It's about vector properties, how do we define and write with them, and also how do we do kind of operations. So because we're introducing a new type of quantity, right, we have to sort of define the operations with them. Kind of like when we started with whole numbers and stuff, then you moved on to fractions. The way that you add and subtract fractions or multiply them is slightly different to how you deal with whole numbers, yeah? So kind of introducing a new type of quantity here. And then probably tomorrow, 3, 4, and 5, these are kind of the more meatier bits of the topic. They're kind of newer concepts, right? Questions so far? There's some nice little clips you can check out later. But so this idea of a vector is commonly defined, as Joel mentioned, as something with magnitude and direction, right? But yeah, when I first read that, I thought that was kind of vague. Like, what does that really mean? One way to think about it is that a vector is a shift. You're moving from one place to another, right? So if you go from this point to another point. The way you describe that shift is I've moved in the left direction for me, right direction for you, and a certain amount. Yeah. So a vector is a shift. I'm moving some amount. You need a magnitude or a length and a direction. Right? So that said, though, the way you define a vector kind of depends on who you ask. Right? So if we ask a physics student, which is pretty much everyone here, you would say it has magnitude and direction. And the best way to represent that is with an arrow, right? Because the arrow very clearly has a length, and the direction, the arrowhead, kind of gives you that. Yeah. Cool. But if you ask someone who does a lot of programming, a vector is something slightly different. They would say that a vector, generally they would say that a vector is kind of like looks like a coordinate, right? And this allows them to program things in a particular way, whether they need to do some movement in a game or construct some sort of like data structure. But that's what a vector means to them. Or art, right? This is actually a vector as well, right? I don't know if anyone's used this before. It's a site called like vector stock. Like, it gives you vector images, and the images are actually created through a series of arrows and curves and things like that. So even art students have a perspective on vectors, right? So what about us as mathematicians? Well, we kind of combine all of these, right? We have these arrow representations. Those are all well and good. We have these column kind of notations here as well, these coordinates, and we can combine them, and we'll do things with images and stuff later as well, right? But yeah, mathematics kind of combines all of these perspectives on what vectors are. And in fact, we've actually done it before. It's actually in the Year 8 course, right? So this is how they look at vectors at an early stage. It's looking at like translating things from one place to another. So what would this look like if we translated the vector, -3, 2? Right, so what's that talking about? I'm talking about a shift, right? So if you think about them now as moving right and down, this is kind of like your x coordinate, and this is kind of like your y coordinate, right? So we could actually shift this by the vector -3, 2. That's why I think the vector as a shift is very good to understand that. Yep, that's the answer for that. Yeah, so moving -3 across, -3 to the left, and then 2 spaces up because we're going negative. Yeah, right. Cool. That's a vector racer game. We can play that later. All right. Definitions and notations. Yeah, we did that. Boom, boom. Okay. So this is the thing with this definition, magnitude, and direction is very good, right? The reason why it's very good is it's very clear what is a scale and what is a vector, right? So if I give you something like length, right? We know that this is a scalar quantity. In fact, all of these are scalar quantities, right? Temperature. So I think I mentioned mass. Yeah, mass is actually a scalar quantity. I think it's just a quantity. It's just a magnitude. But then stuff like displacement, velocity, acceleration, these all have direction now, right? And then weight, as I mentioned, does have a direction as well. But the problem is it's kind of limited, because when you only think about it in terms of magnitude and direction, what about something like this? Y equals the sine of x.
Yep.
Like, what's that? It's a wave, okay. Is it a scalar or a vector?
Depends on what you had for lunch.
I mean, does it, I had bacon and egg roll, but like y equals sine x, does it have magnitude? Or does it have direction? Does it have either of those?
Has many
Magnitudes.
magnitudes.
Yeah, okay. So,
But then each of them has like a grade. That doesn't matter. Wait, doesn't.
I don't know, if I draw the function y equals the sine of x, is there a direction involved? I'll let you think about that one. So these are the quantities that we've looked at, and this one we'll have to have a think about, right?